So with this section, this is going to serve as our bridge to actually our next few units. This is going to take us basically to Thanksgiving. It is the idea that we're going to start exploring in this section. I'm stressing that the ideas we're going to be exploring here are a start. That you're not going to master them entirely here because we have a lot of material that builds up and deepens our knowledge of the basic idea. This is just an introduction to it. So first, I just want to talk about average rate of change. So we're just going to be talking about rates of change here. And I'm going to be dealing mostly with graphs, but a little bit with functions, a little bit towards the end of this section. So here we have an object falling from rest where x is in seconds, y is in feet. The only force acting on it for you physics students is gravity at sea level, ignoring air resistance. So the displacement would be given by the function y equals 16x squared. And I want to find the average velocity between the first and fourth seconds. Well, average velocity in physics is found as the change in y over the change in time, in this case change in x. So it's the change in the displacement over the change in time. Well, if I graph y equals 16x squared, I can do a better graph than that. What I need is the first and fourth seconds. So here's the first second. Here's the fourth second. Well, I would need the coordinates. So if x is 1, I plug 1 into the function, y would be 16. Here, where x is 4, to find y, I plug 4 into the function. 4 squared is 16, times 16 is 256. So the change in y would be 256 minus 16. My change in x would be 4 minus 1. I can choose to simplify this. I am not required to, but I know it's going to bug people if I don't. And I get 80. For units, I can go back to my fraction. I have change in y on top, so the top has to have the same units as y, which is feet. The bottom has to have the same units as x, which is seconds. And there is my average rate of change. Now, what I'm interested in is what we calculated in terms of the graph rather than in terms of an object falling. So yes, this is average velocity, but if I look at my graph, what I found was the slope of that line. Well, I have a line that is intersecting a curve in two places. From geometry, that's called a secant. So I found the slope of a secant. That is going to be the same as average velocity, or as my average rate of change. And again, this is an introduction. I know you've done slopes of secants. You didn't call them secants, but it's old school slope, like you learned back in like 4th grade. You have found average rates of change, but you've never really made an explicit connection between them. And we'll be building on this over the course of the next few months. But kind of the big idea is if you see average rate of change, you're doing a slope of a secant, or the old school slope from grade school.